Welcome back. In this video, we are going to solve problem 3-13 that is taken from chapter number 3, Mechanical Properties of Material. And the book name is Mechanics of Material by R.C. Hibbeler. So statement is a bar having length of 5 inch and cross-sectional area of 0.7 square inch is subjected to an axial force of 8,000 pound. If bar stretches 0.02 inch, determine the modulus of elasticity of the material. The material has linear elastic behavior. So you can see this is the bar having 5-inch length, clear, and there is an axial load of 8,000 pound. And due to this load, it stretches, means change in length will be 0.002. So you have to determine the modulus of elasticity. First, we will write the given data. Bar length is 5 inch. Cross-sectional area is 0.7, axial force is 8,000 pound, and the change in length or bar stretch is 0.002 inch. The material behave elastically, clear? And we have to determine the modulus of elasticity. So let's start with the solution. So as we know that modulus of elasticity, which is equal to E, elasticity, which is equal to E, and that E is equal to stress divided by strain. So we do not know stress and strain. So first we will define or we will determine stress. So stress here is equal to axial load divided by the area over which it acts. So axial load is 8,000 pounds. So I will write 8,000 pounds and area is 0.7 inch square inch. So when you divide it, so you will get 11.43 into 10 raised to power 3 pounds per square inch, or in term of KSI it will be 11.43 KSI. KSI is kilopound per square inch. So you will get 11.43 KSI. Now what we will do is that in second step, we are going to find strain. And you know that strain is equal to change in length divided by original length. Let me write original length, L. So change in length or stretch is given as 0.002 inch, 0.002 inch, and original length of this bar is 5 inch. So inch divided by inch, and you will get 0.000400, and it will be inch by inch or unitless because they will cut each other. Now modulus of elasticity E will be equal to stress over strain. So you have both the values. Stress is 11.43 KSI and strain is 0.000400 inch per inch. So you will get the value of modulus of elasticity will be 28.6 into 10 raised to power 3 KSI, which is the answer of our this question. So this is the modulus of elasticity for the given load and the cross-sectional area for the material. And that was all about this problem 3-13. I hope you have enjoyed this video. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. Also share my videos with your friends and help me in growing my channel further. If you have any question, you can ask me in comment section. Thank you for watching and supporting me.